Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Bridging Between Algebra and Calculus series and concerns using functions. This guide introduces the concept of a function and its associated terminology. It explains domain, codomain and range. It also describes how to use functions with inputs that are either numerical or algebraic. Introduction. Over the past 300 years, the development of mathematical thinking has been closely associated with the evolution of the definition of a function. A function is a very important concept in mathematics, especially in calculus. Functions are also important in many subjects in which mathematics plays a crucial role, such as computer science, economics, and so on. Having a good idea about the different types of numbers which exist in mathematics and the symbols used to describe them is beneficial when thinking about functions. See study guide, different kinds of numbers. You can think of a function as a machine with an input and an output. The function itself controls how the input changes into the output. You have an input. This input goes into the function machine and results in an output. The input can be a number, a letter, or an algebraic expression. The function comprises mathematical operations or abstract rules which act upon the input and result in the output. For example, in economics, the input of the machine may be the quantity of products sold, and the output may be the company profit. The function will control how much profit is made for a given amount of product sold. For example, in mathematics, the input may be x, and the function could be double the input and then add 3, giving the output 2x plus 3. Often, the function itself is represented by a letter which embodies the machinery of the function. Commonly, the letter f is used to describe a function, as it is the first letter of the word function. The input of a function is more properly called the independent variable, or argument of the function, and is often represented in mathematics by the letter x. The output is more properly called the dependent variable, or sometimes the value of the function, and is often represented by the letter y. It is also common to represent the output by the notation f bracket x bracket, which is said f of x, or the value of f at x. It is important that you understand that y and f of x can be used interchangeably. However, there are cases where using y is preferable to using f of x, and vice versa. For example, if it is important that you know what the independent variable is in a function, then f of x is preferable, as the input, in this case x, appears in the brackets. You will often see y or f of x used to label the vertical axis of a graph. You can think of a function f as having an effect on the input variable x to produce something new. In terms of the machine described above, the input is x. This goes into the function machine called f and gives an output of f of x, or y. Common error. It is common to confuse the brackets in the notation f of x with multiplication or factorization. Remember that the notation is used in functions to represent the function f is evaluated at x. You may see examples of this use of brackets in a variety of familiar mathematics, such as sin x and log x. In contrast, the expression 3x multiplied by x minus 2, the brackets indicate multiplication. This is an example of ambiguity in mathematical notation. You only know that f of x does not mean multiply f by x from the context. You should ensure that you are comfortable using brackets in their proper context. A learning enhancement tutor can help you with this. In mathematics, you will commonly see the letters x, y and f used to describe functions. In other disciplines, other, more intuitive letters are used to represent variables and functions. For example, P of t may represent profit P as a function of time t, and V of r may represent volume V as a function of radius r. It is also common for a function to have more than one variable as an input. This is known as a multivariable function. For example, if the area of a shape A is dependent on both its width W and height h, you could write A of WH. Domain, codomain and range of a function. The set of valid inputs of a function have a special name, the domain of the function. The set of all the outputs associated with the domain is called the range of the function, and the range itself is part of a bigger set called the codomain. One important part of the definition of a function is that for each individual element of its domain, a unique output exists. This is a difficult concept which is best illustrated by an example. Example: what are the range and domain of the function f of x equals x squared, where x are the integers from -2 to 2. You can think of the domain of this function as the numbers -2, -1, 0, 1 and 2, which are the integers from -2 to 2, and so are potential values for x. You can think of the function f as a machine which takes one of these numbers and squares it. This is written as f of x equals x squared. The result is part of the range of the function. Take the number 1 as the input of the function. You could say that x equals 1. You can calculate the corresponding output by substituting 1 into the function everywhere you see x. So, f of x equals x squared transforms to f of 1 equals 1 squared, which equals 1. Which says that the function applied to the input 1 gives an output of 1. You can also say that 1 is part of the range. Following this method for each member of the domain, you can see that when x equals -2, f of -2 equals -2 squared, which equals 4. When x equals -1, f of -1 equals -1 squared, which equals 1. When x equals 0, f of 0 equals 0 squared, which equals 0. And when x equals 2, f of 2 equals 2 squared, which equals 4. You have only 3 possible output values, 0, 1 and 4, which make up the range of the function. The codomain is any collection of objects which contains the range. For example, the real numbers and the whole numbers are codomains of this function. There is a neat pictorial way of depicting this concept. In the diagram, the domain is on the left and the codomain is on the right, with arrows that connect them representing the function f of x. So 2 in the domain maps onto 4 in the range or codomain. 1 in the domain maps onto 1 in the range or codomain. 0 in the domain maps onto 0 in the range or codomain. -1 in the domain also maps onto 1 in the codomain or range. And finally, -2 in the domain also maps onto 4 in the range or codomain. The range comprises numbers in the codomain at the end of an arrow. Here the range and codomain are identical. These diagrams are discussed in more detail in the study guide, Functions. Functions with different types of inputs. As you have seen, a function works like a machine which takes an input and transforms it to an output. These inputs are often, but not necessarily, numerical. The method of calculating output values, and hence the range, of a function with numerical inputs was touched upon in the example f of x equals x squared above. Remember, In order to calculate the output corresponding to a specific numerical input, you have to substitute the input value into the function everywhere you see the independent variable, usually denoted as x, and carry out the mathematical operations defined by the function. Example: what is the value of the function f of x equals 2x squared minus 3x plus 1 when x equals minus 2? The input value is minus 2, and so the question is asking you to calculate f of minus 2. Substituting x with minus 2 in f of x equals 2x squared minus 3x plus 1 gives f of minus 2 equals 2 multiplied by minus 2 squared minus 3 multiplied by minus 2 plus 1, which equals 2 times 4 plus 6 plus 1, which equals 8 plus 6 plus 1, which equals 15. So f of minus 2 equals 15. Take care when dealing with the negative sign. You can introduce brackets into a calculation and follow the Oddness system. See study guide. What do I do first? Oddness. The input to a function does not have to be numerical. It can be a letter or even an algebraic expression. A function is simply a set of rules which transforms an input into an output. The function in the previous example, f of x equals 2x squared minus 3x plus 1, can be read as: square the input and multiply the result by 2. Subtract 3 times the input and then add 1. The process of calculating the output of a function corresponding to a non-numerical input is identical to when you have a numerical input. Substitute the input into the function everywhere you see the independent variable, usually denoted by x, and carry out the mathematical operations defined by the function. Example: given that f of x equals 2x squared minus 3x plus 1, what is f of p? The procedure is the same as in the previous example, but as the input is now p, you need to replace x with p. f of x equals 2x squared minus 3x plus 1 becomes f of p equals 2p squared minus 3p plus 1. Example: given that s of t equals 2t squared minus 3t minus 5, what is s of h plus 1? In this example, the name of the function is s and the independent variable is t. You can say s of t. To calculate s of h plus 1, replace the instances of t in the function with the new input, h plus 1. Start with s of t equals 2t squared minus 3t minus 5. Replace t with h plus 1. S of h plus 1 equals 2 h plus 1 squared minus 3 h plus 1 minus 5. This leaves you with some algebra to perform. If you find the following algebra difficult, you can read the study guide Steps into Algebra to help you. So, s of h plus 1 equals 2 h squared plus 2h plus 1, which you get from opening the brackets h plus 1 squared, minus 3 h plus 1 minus 5, which equals 2h squared plus 4h plus 2 minus 3h minus 3 minus 5, which is obtained by opening the brackets, and this equals 2h squared plus h minus 6 by collecting like terms. Example: given that g of theta equals cos theta, what is g of x squared plus 3? Here the input theta has been replaced with x squared plus 3 as the input to cosine. So g of x squared plus 3 equals cos of x squared plus 3. When the input to a function is another function, the output is known as a composite function. For more details, see study guide, More Complicated Functions. Example: what is the value of the multivariable function f of xz equals x squared plus xz plus z squared when x equals 2 and z equals minus 3. To evaluate this, you must substitute 2 for every appearance of x and minus 3 for every appearance of z in the function fxz. So, start with fxz equals x squared plus xz plus z squared. Substitute x equals 2 and z equals 3. This gives f of 2 minus 3 equals 2 squared plus 2 times minus 3 plus 3 squared, which equals 4 minus 6 plus 9, which equals 7. So, f of 2 minus 3 equals 7. Further guidance and information. If you have any further questions about functions or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592 761. Email dos.help@uea.ac.uk or visit our website www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.